Hello, team. This is the start of my sorry, that was my son coughing for you. My absolute favorite chapter of geometry. Chapter 8 is all right triangle trigonometry mostly. There's some that's not right triangle toward the end, but most of what you're going to do is going to deal with right triangles and a lot of trigonometry. And it's super fun. I think you're going to love it. One thing to make sure of throughout this chapter is that you always have your calculator handy, because there are things in this chapter that you just flat cannot do if you don't have a calculator. Your brains cannot come up with it without a calculator. My brain cannot come up with it without a calculator. That's not a bash on you. So keep that in mind. You always need your calculator with you. Back in like the 500s BC, there was this man called Pythagoras, and he was brilliant. And he came up with this first thing that we're going to talk about called the Pythagorean Theorem. You probably learned this in Algebra 1. At least if you went to Valley, you learned it in Algebra 1, because I know Mr. Samuelson teaches it. But you don't do a lot with it. We're going to do a lot with it in this chapter. So here's what it says. If you know the length of two sides of a right triangle, you can find the third side. So here's how we're going to set up our right triangles. You're going to have two legs. Okay, so A and B are going to be the legs of your triangle. C is, tell your neighbor, you should know this. Right, C is the hypotenuse. So the Pythagorean theorem says this. It says if you take your two legs and square them, A squared and B squared, and add them together, you should get the hypotenuse squared. Okay, now this only works if it's a right triangle. So if this is not there, don't use it. Okay, if it's not showing a right angle, don't use the Pythagorean theorem. But most of what we're going to do in this chapter, you will be using Pythagorean, or a lot of, you'll be using Pythagorean theorem. Okay, so with Pythagorean theorem, there are these things called Pythagorean triples. If I were at school, I would show you a silly little intro commercial that we made of me and Mr. Bexford back in the day with baseball. And he is Pythagoras, and he hits a triple, and it's ridiculous, but funny, and makes people remember what they are. So remind me when I get back, and I'll show you that. But a Pythagorean triple is a set of three whole numbers that work in the Pythagorean theorem. So basically, if you can plug it into this and make a true statement, it's a Pythagorean triple. So one example would be 3, 4, 5. That's the most common Pythagorean triple there is. Let me show you. 3 squared plus 4 squared equals 5 squared. In other words, 9 plus 16 equals 25. True statement, right? So 3, 4, 5 is one. I would say probably the next most common that you'll see is 6, 8, 10. Compare that to this, see if you notice anything. We'll talk about that in just a minute. Another one you see a lot is 5, 12, 13. Another one is 8, 15, 17. And then the last just very common one that you're going to see is 7, 24, 25. Okay, so I'm not saying spend time trying to memorize those, but by the time we're done with this chapter, my guess is you'll have those memorized. With Pythagorean triples, there's this cool thing that you can multiply any Pythagorean triple by the same whole number, and you'll get a new Pythagorean triple that works. So like I said here, look up here, 3, 4, 5, and then 6, 8, 10. All of those numbers just got multiplied by 2, and it made a new triple. Okay, if I multiplied those by 3, 3 times 3 would get us 9, 4 times 3 would get us 12, and 5 times 3 would get us 15. So 9, 12, 15 will be a Pythagorean triple. If I multiplied them by 1,000, 3,000, 4,000, 5,000 is a Pythagorean triple. Okay, so you can multiply all the numbers by the same number for any of these. Multiply these by the same number, multiply those, like any of them by the same number, you'll get a new Pythagorean triple. Kind of cool, right? Okay, so what we're going to do is we're going to do a little bit of work with the Pythagorean theorem. And let's take a look at this first one. So these are legs, right? 8 and 15 are legs. This is your hypotenuse, okay? So we're gonna plug this into the Pythagorean theorem. It's gotta be the legs squared and added together. So 8 squared plus 15 squared will equal the hypotenuse squared. Now, here's where your calculator is going to be your best friend. You're going to plug it in. You don't even have to try to figure that out in your head. 8 squared plus 15 squared, plug it into your calculator. You should get 289 equals x squared, okay? Now, from here, your next step is to square root both sides. So square root x squared and square root 289. That makes this x. Always check this first, okay? Plug it into your calculator. And when you plug it into your calculator, I wish I had my calculator sitting in front of me right now. That looks like yours. I think on your calculator, to plug in a square root, you're gonna hit second, and then you're gonna hit the, I think it's the x squared key. And when you do that, it should pop up this on your calculator. If you need to pause this real quick, just so everyone can figure out where that square root button on your calculator is, go ahead and do that. But if you hit second, and then I think that button, and then you just type in 289 and hit enter, this will tell you the square root of 289 is 17. Okay, what that means is 8, 15, 17 is a Pythagorean triple, okay? So sometimes it's gonna work out beautifully like that. Other times you're gonna have to put it into simplest radical form, and that's where we break it down. We did that last chapter a few times, right? With 7-4 especially. So just keep that in mind. If you get 3 whole numbers that work in the Pythagorean theorem, you get a Pythagorean triple. If you need to break this down into simplest radical form, you can do that too. Okay, so example number 2 here. Now look at the difference with this. This time we have the hypotenuse. We have one of the legs, we're missing the other leg. So it's gonna be a squared or y squared plus b squared, right? So this would be our a, this would be our b. A and b are interchangeable, so it could be 10 squared plus y squared, or it could be y squared plus 10 squared, that doesn't matter. But it has to be the hypotenuse. Remember, that's the one across from the right angle. That one has to be by itself. So equals 16 squared, okay? So now from here, what you're gonna do is you're gonna simplify. So this is y squared, 10 squared is 100, 16 squared is 256, okay? So we're gonna take away that 100, and we get y squared equals 156. And now we're gonna square root. Okay, so get your calculator out, and I want you to plug in second, and then that x squared key, and then 156, okay? Take a look at that. When you do that, you get a number 12.489996, okay? That is not a perfect square. So when it's not a perfect square, then you have to do simplest radical form. So we need to break this down into a perfect square and a not so perfect square that 156 is divisible by. So plug it into your calculator. 156 divided by 36. 156 divided by, try all the numbers that you think might work. What you'll notice is the first one that works is actually 4. So you go all the way down. So 156 divided by 4 is 39. So you get the square root of 4 times the square root of 39. And then simplify. Square root of 4 is 2. And the square root of 39 we can't do anything with. So that will be the value of y. Okay. And you can always go back and plug it in and just make sure that it does make a true equation. That's fine too. Yeah, I would say any questions, but I can't answer your questions right now. So we'll try when we get back on Tuesday. I will answer whatever questions you have on that stuff. Okay, example 3. It says you lean a 12-foot ladder against a house. the base of the ladder is 4 feet from the house. Okay, so 12-foot ladder, 4 feet from the house. How high on the house does the ladder reach? Okay, so what you're gonna do is, I gave you a little house there to work with. Isn't it cute? It's not the color scheme I would have gone with for my house, but you know, cute nonetheless. So it says a 12-foot ladder leaning against a house 4 feet from the house. So the base of the ladder is 4 feet from the house, and then the ladder itself is leaning on the house. Okay, the ladder is 12 feet. How high on the house does the ladder reach? So what we're looking for is this length. We'll call that X, okay? Notice if it's leaning against the house is vertical, the ground is horizontal. So this is where your right angle would be in that situation. So basically what you're looking at is this. You have 4, 12, and X, all right? That's your setup for your triangle. So now what you're gonna do is you're gonna do the Pythagorean theorem with that triangle, but pay attention to where your things are. You have a leg missing and you have the hypotenuse, okay? So that means X has to be either your A or your B. 4 is your A or your B, but this has to be your C value because the hypotenuse has to be the standalone, okay? Across from the right angle is always by itself. So we're gonna say X squared plus 4 squared equals 12 squared, okay? So that's X squared plus 16 equals 144. And then we're gonna take away the 16. So we get X squared equals 128. Okay, now typically I'm gonna ask you to put things in simplest radical form when it comes to these types of problems, unless it's a real world problem, which this one is. This one says round to the nearest 10th of a foot. So here's what you're gonna do. Square root both sides. So X equals, and now you're gonna do that same thing again. The second key, and then I think the X squared key, I hope I'm not leading you astray. Right above it will be this little symbol. So whatever button on your calculator has this little symbol right above it, that's the one you wanna push. I think it's X squared. I really hope it is. And then 128, and then hit enter. Okay, when you do that, the square root of 128 comes out to, if we round to the nearest 10th, 11.3, and then don't forget to label it. This is feet, so 11.3 feet. Okay. Okay. Then there is also a converse to the Pythagorean theorem. And remember what a converse is. A converse just takes the hypothesis and conclusion and swaps them, right? So we said before, if something is a right triangle, then a squared plus b squared equals c squared. That's the Pythagorean theorem. The converse says if a squared plus b squared equals c squared, then the triangle is a right triangle, okay? So they're gonna ask you, is this a right triangle? So they give you 3 side lengths here. They give you 12.5 and 30 and 32.5. Now to check it, your hypotenuse is always your longest side, right? So you always have to make the longest one your C. So like in this case, that would be C. In this case, that would be C. Sometimes they're not in order, so just make sure your C is always the one that's the biggest, and that one is by itself. So we would do here 12.5 squared plus 30 squared should equal 32.5 squared. So we're asking, does it equal here, okay? Now here's all you do. 12.5 squared in your calculator plus 30 squared, okay? All is one thing, hit enter. 12.5 squared plus 30 squared, I get this number. 1056.25. Okay, now type in 32.5 squared in your calculator and you get this number. Okay, because they're equal, right? This checks out, they are equal. Is it a right triangle? We would say yes, this is a right triangle. Okay, and make sure you have the work there to show me why. You don't need to explain it in words. If you show me this, that's all you need. okay? So letter B, then you have 16 squared plus 48 squared should equal, does it equal 50 squared? Okay, so plug that into your calculator. 16 squared plus 48 squared is 2,560. Does that equal 50 squared? So plug in 50 squared in your calculator and you get 2,500. Okay, because those are not equal, we would say this is not a right triangle. Okay, so basically you're just taking the Pythagorean theorem, plugging it in, plugging the three numbers into it, and telling me yes or no. It's right or it's not. Okay, but now the next thing we're gonna do is gonna say, well, if it's not a right triangle, then can you tell me something about it? Is it an obtuse triangle? Is it an acute triangle? And you can tell that from the numbers that you get, which is what you see right up here. Okay, this one says if c squared, so if your hypotenuse squared is bigger, right? So not this one. This one, the hypotenuse squared was smaller. But if your c squared, if your standalone number squared is bigger than the sum of the other two, then that triangle is going to be obtuse. Okay, and again, I wish I could show you kind of an example of this with my arms. Think of it this way. Okay, here's a right triangle. If I open up this angle a little wider, okay, so now this is my angle instead. What happened to that third side? It got longer, right? So if c squared is bigger, it's an obtuse triangle. But let's say we have a right triangle and I make that right angle smaller, okay? Now my c squared just got shorter, right? If this angle here is acute, I made it smaller than 90 degrees, then the c is smaller, okay? So maybe that's how you can kind of remember it. If c squared is smaller, okay, if your c squared is less than the a squared plus b squared, then that triangle is going to be acute, okay? And that's the last thing we're gonna do is we're just gonna try 4 of these and see if you can think your way through it. So let me show you on the first one, and then I'm gonna have you try the second one on your own for a minute. And maybe with a neighbor or talk through it and tell them what you think, and we'll go from there with the other 2 then. Okay, so 4, 9, and 12. That means this has to be c, okay? C squared is your biggest one. So it's gonna be 4 squared plus 9 squared somehow relates to 12 squared, okay? So let's plug this in. You're gonna plug 4 squared plus 9 squared into your calculator, and you get 97. So 97 somehow relates to 12 squared, which is 144. Okay, so that means my c squared is bigger, right? This is the c side. This is the a squared plus b squared side. My c squared is the bigger one. We said if c squared is bigger, that is what type of triangle? That's an obtuse triangle, right? Because your c squared is bigger. And again, I don't need you to tell me this portion of it as long as you show me this portion of it, okay? Okay, so here's what I want you to do. I want you to lay out your B here in the Pythagorean theorem and tell me, is it acute, is it obtuse, or is it right? And I'm just gonna leave this rolling for about a minute while you plug that in, and then we'll chat about what it is. Feel free to talk to your neighbors right now. I'm still recording. My children say hello. All right, so let's see what you did. Tell your neighbor what you got real fast. I'm gonna set this up. So this is gonna be your C, right? The biggest one is your C. So 7 squared plus 8 squared somehow relates to 9 squared. Okay, if you plug that in, 7 squared plus 8 squared is 113. 9 squared is 81. So your symbol would go this way, right? 113 is bigger than 81. That means C squared is the smaller. And again, if you go back up, when C squared is smaller than A squared plus B squared, that is an acute triangle. So we would say this one is acute because your C squared is smaller. Okay, letter C here. If we plug that into the Pythagorean theorem, we get 12 squared plus 13 squared somehow relates to 15 squared. Any guesses what this one will be? Let's plug it in. 12 squared plus 13 squared is 313. That somehow relates to 15 squared, which is 225. Okay, so A squared plus B squared is bigger, meaning C squared is smaller, which makes this acute. Okay, letter D. Any guesses on that one? If you go back up to the top of the page, you should be able to tell me. Well, let's plug it in. So 7 squared plus 24 squared, right? This is your C, has to be by itself, somehow relates to 25 squared. So if you plug it in, 7 squared plus 24 squared is 625. 25 squared is 625. So those are equal, making that what kind of triangle? Do you guys know?
Huh?
Were you listening to me?
No.
No?
Could you say it again? I bet I could.
If A squared plus B squared equals C squared, it's what kind of triangle?
Three-pointed.
No. It is a right triangle. Sorry, just quizzing my children. I thought they were listening to me. So that would be a right triangle, okay? So those are your three options: obtuse, acute, or right. All with the Pythagorean theorem. You're going to be very good friends with this by the end of this chapter, okay? A squared plus B squared equals C squared. If it's a right triangle, that will be true. If that is true, it will be a right triangle. All right. So 8-1 is due on Tuesday. You don't have school on Monday. Enjoy your break. Remember Martin Luther King Jr. and the good work that he did. And yeah, I hope to see you on Tuesday. That's my plan. Have a lovely weekend, and we'll see you soon.